Good evening, I'm Dinasharana Muniandy from SKEE 2523 section 02, and today I'll be explaining about the application of electromagnetism in magnetic resonance imaging, which stands for MRI. So an MRI uses electromagnetic fields, which uses the concept of magnetostatics. So magnetostatics is the study of magnetic fields in systems where the currents are steady and does not change with time. It is the magnetic analog of electrostatics, where the charges are stationary. So magnetostatics focusing can be achieved either by a permanent magnet or by a passing current through a coil of wire whose axis coincides with the beam axis. So these are some of the applications that uses magnetostatics. First, a small part of electromagnetism is used for the usage of the computer memory in every computer. Next is polybells, and the third one is magnetic resonance imaging, MRI. So another natural use of magnetostatics is lightning. So what is magnetic resonance imaging? Magnetic resonance imaging, MRI, is a medical imaging technique used in radiology to form pictures of the anatomy and the physiological processes of the body. MRI scanners use strong magnetic fields, magnetic field radiants, and radio waves to generate images of the organs in the body, which an X-ray can't be done, because an X-ray can only scan the bones of the human body, while else the MRI scan it could scan anything that is other than the human bones. So this is the basic structure of the MRI scanning machine. So as you can see, this is the circular cylindrical shape where the human goes through the middle, and surrounding it is the radio frequency coil, gradient coils, the magnets, and below it is the scanners. Here, as you can see, is how the scanning works. As you can see, this is the magnetic field that moves around the MRI machine. So as you can see, the MRI machine basically uses 1.5 to 3 Tesla powers. So how much does one Tesla power is actually equal to 5 Gauss. So an MRI scan is actually a machine that forces protons in the body to align with the field. So from where the proton comes is from the hydrogen particle, which has a singular proton in our body. So this is where the magnets attract the protons to align to show the scan in the body. So when a radio frequency current is then pulsed through the patient, the protons are stimulated and spin out of equilibrium from their current state, so straining against the pull of magnetic field in the body. When the radio frequency field is turned off, as you can see, this is the radio frequency coil. So when the radio frequency field is turned off, the MRI sensors are able to detect the energy release from the proton. So as the protons are realigned with the magnetic field, it takes time for the protons to realign with the magnetic field, as well as the amount of energy released, which change depending on the environment and the chemical nature of the molecules. So basically this is how an MRI scan works. Thank you. Have a nice day.